we're going to continue to look at parallel lines cut by a transversal in section 2.3, and we've already gone over these postulates. I've also talked about the naming conventions here. So here we have theorem 2.1.2. That means that this was covered in chapter 2, section 1. This was covered in section 2.1, which we have already covered. So we've seen this material before. But what I want to point out to you is these theorems state if two parallel lines are cut by a transversal, then the corresponding angles are congruent. We know that. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So if this condition, then the angles are congruent. If this condition, then the angles are congruent. If this condition, then the angles are congruent. Continuing with what we've already learned in section 2.1, if two parallel lines are cut by a transversal, then same side interior are supplementary. If two parallel lines are cut by a transversal, then same side exterior angles are supplementary. So now, if we know those are true, and if you remember something about a definition, it's reversible. The only difference in section 2.3 is what information are we given as true? What are we starting with? What condition are we starting with? It might look like they're saying the same thing, but they're not saying exactly the same thing. The if and the then parts are swapped. So we're in section 2.3, and notice this is a new theorem, theorem 2.3.1. If the condition for this theorem is if two lines are cut by a transversal so that the corresponding angles are congruent. So if you have lines and the angles are congruent, then the lines are parallel. So all of these theorems and postulates in this section are going to end with then the lines are parallel. In section 2.1, we started with if parallel lines were cut by a transversal. We started with the assumption that the lines were parallel and came up with conclusions about the angles. These theorems, we start out with assumption about the angles, and we can draw a conclusion that the lines are parallel. You say, well, why do I need them both? Well, sometimes you're not told the lines are parallel. You have to deduce that lines are parallel. And you can't just say, well, they look parallel. You have to be able to prove that they're parallel. So here we have if line L and line M, and we don't really know, here's line L and line M, and they're cut by a transversal, and we're told that angle 1, angle 1 is congruent with angle 2. These are corresponding angles. If the corresponding angles are congruent, then the lines must be parallel. And that's what all of these theorems are going to look like. We start with conditions or assumptions about the angles, and we end with then the lines are parallel. So here we have if two lines are cut by a transversal and alternate interior angles are congruent, then the lines must be parallel. So we're ending with then the lines are parallel. Okay, if two lines are cut by a transversal and alternate exterior angles are congruent. So here's two lines cut by a transversal. So if 4 and 7 are congruent, they are alternate exterior angles. So these lines must be parallel. Now, sometimes when you get complicated diagrams, it is hard to tell which lines are the lines and which line is the transversal. And so we could use some practice with that. So, suppose we're told that angle 1 is congruent with angle 3. Here's angle 1 and here's angle 3. How do we know which lines are parallel? How do we know, is it CD that's parallel or is it AB that's parallel? Well, you have to look at the diagram and look at the lines that are used to create angles 1 and angles 3. So in other words, I'm talking about this angle and this angle. Is line D involved at all with these two angles? No. Line D is not involved with the creation of these two angles, so we must not be talking about C and D being parallel. We must be talking about A being parallel to B, which is going to make C the transversal. Two parallel lines cut by a transversal. That makes 1 and 3 corresponding angles. And the corresponding angles were equal. So we're going to practice this a little. Sometimes it takes a little practice when we get into some complicated diagrams. The question here is, in these figures, which lines must be parallel? So for this first scenario, I'm told angle 3 and angle 8. Angle 3 and angle 8 are congruent. So look at the points of the vertices of the angles. That's the vertex of angle 3, that's the vertex of angle 8. Is line A involved at all with those two vertices? No. So line A is not one of the parallel lines. So that must mean C is parallel to D. And that must mean that B is the transversal. How about here? Angle 5 is congruent with angle 9. And we really want you to know how to find this. We don't want you just guessing, because when you're making logical deductions, you want to make sure you're using true information. So here's the vertex for angle 5, here's the vertex for angle 9. Obviously, line C has nothing to do with those points, so it must be that A is parallel with B, and D is the transversal. And here we're told angle 1 is congruent with angle 8. Okay. Is there a line that the vertex for both angle 1 and angle 8 is on? No. So none of these angles have to be parallel. I mean, they might be, but they don't have to be. So we cannot draw any conclusions from that diagram at all regarding which lines are parallel. So that had to do with corresponding angles and alternate interior angles and alternate exterior angles. The same concept applies to these theorems. We're going to end with, then the lines are parallel. But these are the two conditions that were covered in section 2.1. Same side interior being supplementary. And same side exterior angles being supplementary. Not congruent, but supplementary. If two lines cut by a transversal such that same side interior or same side exterior angles are supplementary, then the lines must be parallel. And then here, if two lines are parallel to a third line. Okay, so here's line A. And I'm telling you that line A is parallel to line K. A is parallel to K. And then here's another line that's parallel to K. Here's line G. And you know what? G is also parallel to K. So if A is parallel to K and G is parallel to K, we must know that A is also parallel to G. That's what two lines are parallel to a third line. They're parallel to each other. And the same is true if they're each perpendicular to a third line, then they are parallel to each other. Let's draw that one. So here's line A. And I'm going to say A is perpendicular to B. They meet at a right angle. A is perpendicular to B. Well, you know what? If I have a third angle, a third line here, here's C, and C is also perpendicular to B. A is perpendicular to B, C is perpendicular to B. Well, if they're both 90 degrees to B, that must mean A is also parallel to C. So sometimes you have to draw a diagram to prove that these theorems are true to yourself.